Pythagorean theorem works for right triangle only. So where a squared plus b squared equals c squared, that's the rule, that's the theorem. Side C is the hypotenuse, the longest side. Side A and B are the two legs. So side A and B are the legs. Yes, you can see it here. The legs. And then the longest side, the hypotenuse. So the leg squared, the smaller leg squared plus the larger leg squared equals hypotenuse squared. Find the missing side of the triangle value of x or hypotenuse. So in this example, you are just finding the missing side, which is the largest side of the triangle. In other examples, you are finding the legs. So given a equals 6 from our figure here, b equals 8 and c equals x. So a, b and c. Our legs are a and b. So we plug it in the equation. A squared plus b squared equals c squared. So if 6 squared plus 8 squared equals c squared. Just recall 6 squared is 6 times 6. 8 squared is 8 times 8. C squared is c times c. So you have 36 plus 64 equals c squared. When you add 36 and 64, it's 100. 100 equals c squared. Now we need to do inverse operation for square. So inverse equation of square is square root. So we're going to take square root both sides. So square root of 100 is 10, which means square root of 100, what it means when people don't know. Square root of 100. What two numbers, same numbers, multiply gives you 100. So it's 10 times 10. So if we do square root of 10 to the power 2, these two cancels out. We are left with 10. So if we are looking for two same numbers that multiply. Okay, so our largest side, the hypotenuse is 10. Find the missing side of the triangle leg A. So we see leg A is x, and then we have b, and then we have the hypotenuse c. Given a equals x, b equals 4, and c equals 5, we use the formula a squared plus b squared equals c squared. We plug in the corresponding values. So we have x squared plus 4 squared equals 5 squared. Then 4 squared. Recall 4 squared. 4 to the power 2 is 4 times 4, which is 16. And then you have 5 squared is 5 times 5, which is 25. 4 squared is not 4 times 2, and 5 squared is not 5 times 2, which is the commonest repeater. So we have x squared plus 16 equals 25. Now we want to isolate x. we want x squared by itself. We want x squared by itself. So we have to undo addition because 16 is added. In order to cancel out 16, we have to subtract 16 both sides. We do opposite operations. So this goes away if we subtract. Okay. So 25, we have x squared equals 25 minus 16, which is 9. Now we want x to the power 1, not x squared, not x to the power 2. We want x to the power 1. So the value for x to the power 1, how will we find that? We take the opposite of square, which is square root, both sides. We square root both sides. So square root of 9 is 3. So a is 3. The leg a is 3. This is 3. Value. Find the missing value side leg B to triangle and leave your answer in radical form. So this time side B is missing. So side A, side B, and side C. The hypothenuse and the two legs. So A is 6, B is x, and C is 11. So now we need to find leg B. You have noticed in my slides I am labeling the short one as A and the long one as B for the legs, and C for hypothenuse. AB switch doesn't matter, but hypothenuse should remain C. It's the other side of the equal sign, and the legs are both on the other side. Okay, so you have a squared plus b squared equals c squared. Plug it in. Again, squared is 6 times 6, which is 36. 11 squared is 11 times 11, which is 121. So we plug it in. We have 36 plus x squared equals 121. Now we want to isolate x squared. So 36 is added to x squared. We have to undo addition, so we subtract both sides. 36, we are left with x squared equals 85. Now we want x to the power 1, not 2. So we take square root both sides. We have x equals 80, square root of 85. X equals square root of 85. So C is square root of 85.